going to be asked to identify whether functions are even or odd functions. Okay? For something to be an even function, the following rule exists. Okay? Even functions exist when you can replace every x inside the function with a negative x, and it's the exact same as the original. Okay? So if f of x is equal to f of negative x, then you have an even function. Okay? Basically, the rule for this is all variable terms are going to have even powers. Okay, so if all the variable terms are taken to even powers, you're going to have an even function, and these are symmetric to the y-axis. Okay, an even function can fold across the y-axis, so the left half and the right half of the graph folded at the origin or at the y-axis will map directly on top of each other. Okay. For an odd function, okay, so when you're looking at odd functions are going to be functions where when you replace the original function, when you replace all of the x's with a negative x, it's going to equal the opposite of the function, meaning if you change the sign of every single term in the function. If those are equal, then you have an odd function. And so again, another way to think of it is that all the variable terms are going to be taken to an odd power. Okay? And if this happens, it's going to be called symmetric to the origin. Okay? And if something is symmetric to the origin, what that means is you can rotate the graph 180 degrees, and it's going to map onto itself. Okay? So if you rotate the graph at the origin 180 degrees and it maps onto itself, you have an odd function. So to test whether a function is even or odd, one way you can do it is to use these formulas. And you can test first for an even function. If you take the original function, replace and evaluate with f of minus x, and then compare that to the original function, you can see if it's even. So here in this example, 4 times a negative x cubed plus a negative x, and if you simplify what you have, negative 4x cubed minus x, that is not the same as the original, so we know it's not, this example is not an even function. We can test for an odd function by now comparing minus f of x, again doing this comparison. And if we take a minus f of x here, we're changing the sign of each term. And here when we compare that to our f of minus x, these are exactly the same thing. That means that this would be an example of an odd function. Okay, same thing here with this second g function. If we test it for g of minus x to see if it's an even function, we get a negative x cubed plus 4 gives us negative x cubed plus 4. That does not equal the original function, so it's not even. We can now test for odd. If we take a negative g of x, change the sign of each term, so negative x cubed minus 4, and then compare that to our g of minus x. These are different. So this second example would be a neither. And then finally, this h of x, if we evaluate h of minus x to test if it's even, we get a 4 minus a negative x squared becomes 4 minus x squared. When we compare that to the original, they are the same. So this would be the even function. Okay, so let's take a look at some of the ways that you're going to do this. Okay, so first let's look at the graphs, because looking at the graphs is the easiest way to determine if something's even or odd. Okay, so if you were to imagine a vertical line right down the y-axis, if you fold the graph and it maps directly onto itself, it's an even function. So does this graph fold directly onto itself when I draw that vertical line down the origin? Yes. So this one is called an even function. Okay, what if I draw this line straight down the origin? Does that map onto itself? No. And what about this one? No. Okay. Now it can, when you fold it right there, this part comes over the top. So it's the only even function is this first one here. Okay, now when we test for odd functions, what we're looking at is, can we take this graph and rotate it? So if we rotate this graph 180 degrees, does it map back onto itself? This one does. So this is called an odd function. It's symmetric to the origin. Okay, if I rotate this, again, from this point right here, so it's not just the graph itself, but if I rotate that 180 degrees, does it map onto itself? No, it does not, because this point down here is going to wind up in quadrant 4, and so it's not going to map onto its original self. So this one would be considered neither. Okay, so just looking at a graph, it's usually pretty easy to determine whether it's even, odd, or neither. Okay, now, when you're looking at the equations of them, using the rules from below, so this set of rules and this set of rules, is often the easiest way to do it. So when you look at this first function f, here we have an odd power. Here we have an unwritten power of 1, so that's an odd power. So if all of your terms, every single term, has a variable power of that's odd number, then your function is going to be odd itself. So this right here, you know, is going to be an odd function. Okay, when we look at g, we have an odd number here. And again, when you have a constant, you need to think of it as unwritten power of x to the 0, right? So if you think of what the degree is here, this 0 is an even number. And so when you're looking at these, this one does not have all odds or all evens, so this would be a neither. And then finally here, if you think of this as x to the 0, you have even. 2 is even. So here all of your terms have powers that are even, so that means this is going to be an even function.